All right. So now we are going to start with 3D shapes. Okay. So mensuration, and we're going to start with 3D shapes. All right. So we are going to discuss cube, cuboid, prism, pyramid, cylinder, cone. All right. Let us start with a basic 3D shape, that's cube. But before that, you should know that what is volume and surface area. We're going to deal with volume and surface area in mensuration and of 3D shape. So basically volume. Basically, what is volume? The volume of an object is the measure of how much space it occupies. Volume is the measure of space occupied by an object. Okay, there is a difference in the volume and capacity. Basically, volume is a space occupied by an object, and capacity is the amount of matter something can contain. The maximum amount of matter something can contain, right? Let me just clear it with a very simple example. For example, you have a bottle of 1 liter. For example, you have a bottle of 1 liter. Let's suppose this is a bottle. Let's suppose this is a bottle of 1 liter. Now, right now, it is the bottle that is of 1 liter. For example, it is half filled with water. It is half filled with water. It's a bottle that is of 1 liter and it is half filled with water. So the capacity of this bottle is 1 liter. And the volume, what is volume actually? It's the maximum, it's the measure of the space occupied by an object. So the volume in it is, it's half filled. It means it is half liter, or you can say 500 cubic centimeter. As 1 liter has 1000 cubic centimeter, so half liter means 500 cubic centimeter. So the volume is half liter, right? So volume is the amount of liquid in an object. It's the amount of liquid present in an object. It's the amount of liquid present in an object. That is half liter. And capacity is the maximum. It's the amount of matter something can contain. It's the maximum, space in an object. It's the amount of matter something can contain. So the capacity of this bottle is 1 liter, but the volume of water right now in it is half liters. That is 500 cubic centimeters. So this is a basic difference in volume and capacity, right? So in mensuration, we'll be just talking about the volumes and the surface area. The other thing is surface area. Now, what actually a surface area is? All right. So surface area, when we talk about the surface area, it's the area occupied by an object, right? Area occupied by an object. Then comes to your mind that what's the difference between the simple area and a surface area. Basically, simple area, we talk about 2D shapes, that the area is the inside, the space inside an object. So surface area means we always talk about the 3D shapes. For example, if we talk about the surface area of a cube, so we'll see that how much the space the cube occupied, how much area the cube occupied when it will be opened, right? So when we talk about the surface area, we should be very clear about the nets of the 3D shape, right? The nets of a 3D shape. So for surface area, the nets of 3D shape should be Clear? All right. So let us just start with a simple 3D shape. That's a cube. That's a cube. Okay. Let me just make a cube for you people first of all. Okay. So cube. So the basic properties of cubes, it has 6 faces. It has 8 vertices and it has 12 edges. 6 faces, 8 vertices and 12 edges. All right. So, and it has all the lengths, right? It's a 2D, its 2D shape is square. It's a modified form. It's a cube. So the 2D shape is a square. Okay. So for the cube, the volume is length times length times length. That is L cube. That is L cube. For the surface area, it is how many faces a cube has? It has 6 faces. So surface area means the area occupied by the object. So 6 faces means 6L square, as one face of a cube is a square and it has area L square. So 6 faces would be 6L square. All right. Now let's suppose that it's a open cube. It's a open cube. What actually is an open cube? Yes, it doesn't have a top, right? Or doesn't have a bottom even, you know. So it has, how many faces would it have then? It has 5 faces. So the surface area of open cube will be 5L square. It has 5 faces. So it would be 5L square. All right, let's just again recall it once again. Cube, the volume is L cube. The volume of a cube is L cube. And the surface area would be 6L square for a closed cube. And for open cube, it is 5L square, right? L cube, 6L square, and then 5L square. Done with the cube? Okay, let's talk about cuboid. Okay, so now this is a cuboid, right? Length. Okay, length, width, and height, right? Again, let's talk about the properties. It has 6 faces, right? It has 8 vertices. It has 12 edges. Okay, so the volume of cuboid would be length times width times height. Length times width times height. Length times width times height. Now let's talk about the surface area of cuboid. Okay, for surface area of a cuboid, please try to understand that how a cuboid is made. Okay, so see, this is the base. It includes length and width. This is length and this is width. So base, this is base and this is top. So that means that 2 times length, width. 2 faces are done. So out of 6, 2 are done. How many are left? 4. So we are done with base and top. Now let's talk about the front. So this is a front of a cuboid. So the front face has length and height. Length and height. So the front face has length and height. So do the back face. So 2 times length, height. Right? Length and height, length times height for this front face, as it's a rectangle, length times height. And the back face again, length times height. So 2 times length into height. Now, we're done with base and top. We're done with front and back. We are left with the sides. So this is a side. So this side has width and height. The right side and the left side. 2 sides we have. So 2 times width and height. So this is the formula for the surface area of a cube. 2 times length width plus 2 times length height plus 2 times width height. Right? Right? Okay. Base and top, front and back, base top, front back, and sides. Right? Okay. Now, if it's a open cuboid, then what would happen? Surface area of open cuboid. Okay. Surface area of open cuboid. Obviously, when the cuboid would be open, which side, which face would be missing? Yes, it can be it's the top one, right? So this would be missing. I'm going to exclude this face, the top one, the top one. I'm going to exclude this face, the top one. Okay, all right. So let's come over here. This was the formula for the surface of a cuboid. 2 times length width. That includes the base and the top. So now we are going to exclude the top face. So it would be LW instead of 2LW. And the rest formula will remain same. Right? LW plus 2LH plus 2WH. I hope it's clear. Okay. So we're done with cube. We're done with cuboid. For the cuboid, we have the formula for the volume, length time, width time, height. Right? And the surface area is for closed 2LW plus 2LH plus 2WH plus for open LW plus 2LH plus 2WH, right? Okay, now let's talk about prism. Okay. What is actually a prism? Okay, it's a 3D shape. It's a 3D shape with constant, or you can say same cross section along its length. If you are able to identify a prism, then there is no problem in solving the question. You should know that how does a prism looks like. It's very simple. It's a 3D shape with constant cross section along its length. For example, let me just make up this. Okay. All right. Okay. So this is a prism. See, the cross section is every time a triangle. Look, this is a triangle. Again, this is again a triangle. This is again a triangle. So the cross section is every time a triangle, right? So a 3D shape with constant cross section along its length. So that's a prism. Now the formula is very easy. So the volume of prism is base area times height. Base area times height. Or you can say that area of cross section times height. Some of the people say base area, some says area of cross section. It's same, right? So for the prism, if you are able to identify the cross section, then it's very easy to find out the volume. Now here the cross section is triangle, and you know that the area of triangle is half times base times height. So this is the base area times the height, means the height of the, this is the height of the prism. This is the height of the prism, and this is the height of the triangle. Do not get confused in it. One is the height of the prism, the other is the height of the triangle. This is the height of the prism. This means that this height, the height of the prism, and this height is the height of the triangle. This height is the height of the triangle. Let me clear this to you again. This is this height, the height of the triangle. This is the height of the triangle, right? And that's the height of the prism, right? So its a formula is base area times height. Base area times height. Okay. Now, let's talk about pyramid. Let's talk about a pyramid. Okay. So, alright. So this is a pyramid, right? So the volume of, it's a square base pyramid, right? It's a square base pyramid. So the formula of pyramid is 1 over 3 times base area times height. Again, for the base area, you should be very clear that what actually the base is. Over here, the base is a square. So what's the formula for the area of a square? Come on, yes, L square. So L square, you're going to put in the formula 1 over 3 times the base area would be L square times height. So again, whatever is the base, just use the area of that particular base for the volume of a pyramid, right? So the volume of a pyramid is 1 over 3 times base area times height. 1 over 3 times base area times height. All right. Now, let us just start with the next one. That is a cone. Okay. Cone. Okay. So cone looks like this, right? Okay. For cone, first of all, there are few things that you should be very, very clear about. The very first thing is okay, let me just make a cone the other way. Okay. So this is the base of the cone, right? This is the radius. It has a circular base. Okay. This is the height of the cone. And this slant is the, this is the slant height. This is the slant height, which is represented with L. It's the slant height. This is the slant height. This is the normal height. And this height is always perpendicular to base. And this is the radius of cone. Okay? And now the formula for the volume of cone is 1 over 3 times base area times height. Here the base is, what's the base over here is? Here the base is a circular base. And for circle, we have the formula pi r square. So 1 over 3 pi r square h is the formula for the volume of cone. Is the formula for the volume of cone. Okay. Now, let's talk about the surface area of cone. Surface area of cone. So the surface area means the area it occupies on a surface. So this is a base, right? It is circular. So it has pi r square. And this is the curved surface area, that is pi r l. So for surface area of cone, we have two areas, the base area the base area and the curved surface area. Base area plus curved surface area. So the base area is pi r square and the curved surface area is pi r L. So pi r plus L. You can use this form or you can use this form. So for the cone, we have a surface area as the base area plus the curved area. The base area plus the curved surface area. So the base area, we have pi r square. And for the curved surface area, we have pi r L, as you can see over here. Pi r square plus pi r L. So this is the formula for the surface area of cone. This is the formula for the surface area of cone. All right. Now let's talk about a cylinder. Okay. Let's talk about a cylinder. How does a cylinder looks like? Okay. This is the formula for, this is a cylinder, right? Okay. So volume of cylinder is pi r square h. Pi r square h. And for surface area of cylinder, we have, what do we have? Again, we have this, and we have this. Let's just make a net of a cylinder. So the net of a cylinder looks like this. Right? So we have three things. We have this circle that is pi r square. We have again this circle that is pi r square, and this is 2 pi r h. This is 2 pi r h. This is the height, and normally we assume that whatever this length is, it is equal to the circumference of this circle, and it actually is. Whatever the circumference of circle is, this is actually this length. This is 2 pi r and this is 2 pi r and h. Anyhow, just don't remember it. The formula is important. So the formula is pi r square plus pi r square. That makes it 2 pi r square plus 2 pi r h. 2 pi r square plus 2 pi r h. The formula is 2 pi r square plus 2 pi r h, right? 2 pi r square plus 2 pi r h. Okay, we can write it like this also. 2 pi r plus h. You can use any form like this or this. Okay, so we are done with the cylinder. Yes, a question might comes that surface area of open cylinder. So what happens when it would be an open cylinder? Obviously, we're going to consider this phase. This would be omitted. So it means that this wouldn't be there. So the formula will be only pi r square plus 2 pi r h. Right? And yes, there can be another thing asked, that surface area of pipe. As the pipe is like a cylinder, it doesn't have a top and a bottom. Pipe doesn't have top and bottom. So when we have this kind of scenario, we don't have to use this pi r square and this pi r square. The formula will be only 2 pi r h, right? So when we have the cylinder, the formula is 2 pi r square plus 2 pi r h. When we have open cylinder, only the top is not there, right? Like you can say it can be a glass. You can say it can be the open tin, right? So we have pi r square plus 2 pi r h. When we have a surface area of a cylinder, like it can be a pipe. It doesn't have a top and a bottom. The formula is only 2 pi r h. That is 2 pi r h. Okay. And the volume of a cylinder is pi r square h. I hope it's clear. All right. Now, let's just start with the last 3D shape. That's a sphere. Okay. So it's a it's a sphere. Okay. Let's just make a sphere. Okay. So for sphere, the formula for volume is the radius 4 over 3 pi r cube. And the formula for the curved surface area of sphere is 4 pi r square. 4 pi r square. Okay? It is 4 pi r square. It is 4 pi r square. Now, let's talk about a hemisphere. Okay. So we have two types over here. This is a hemisphere. It is half of a sphere. We have two types here. The one is the solid one. First is the solid one, and the other is the hollow one. Right? The first is the solid one, and the other is the hollow one. So for hemisphere, basically the formula for the volume is 4 over 3 pi r cube for sphere, and it is divided by 2 for a hemisphere. Or you can say that 4 over 6 pi r cube, or you can say 2 over 3 pi r cube. I hope that you know how it becomes 4 over 6. When I divide 4 over 3 divided by 2, this is 4 over t times 1 over 2. It makes 4 over 6. And upon simplifying, it makes 2 over 3. Okay. So this is for the volume. Now, this is for the volume. Let's talk about a surface area of a hemisphere. So the surface area of a sphere is 4 pi r square. So 4 pi r square. When I'll divide it by 2, it would be 2 pi r square for the surface area of a hemisphere. But here I have talked about the solid and a hollow. So what happens when we have a solid hemisphere, and what happens when we have a solid hemisphere, and what happens when we have a hollow hemisphere? All right, this is autocorrect, and this is like this. Okay. Let's suppose this is solid and this is hollow. Okay. So this is again a circle. Okay. So this is pi r square, right? This is again pi r square, and this is 2 pi r square, and it is a half of a hemisphere. So for this solid, the surface area, the curved surface area is 2 pi r square plus pi r square. This is a solid hemisphere. And for this hollow hemisphere, the curved surface area, we're not going to take this pi r square. That is only 2 pi r square. That is only 2 pi r square, as it is a hollow hemisphere. As this is a hollow hemisphere, it would be only 2 pi r square, right? It is only 2 pi r square. Okay. It's only 2 pi r square, 2 pi r square, right? So we are done with all the 3D shapes. That starts with a cube, then cuboid, then we are done with the prism, pyramid, we are done with cylinders, we're done with spheres. Okay, so let us just discuss one example. All right. Okay, for example, let's suppose we have a hemisphere over here that is like this. Let me just make it. Okay. And on the top of it, it's a cone. It's a cone sitting on a hemisphere, right? So basically, you know that this is R, right? For cone, we have this height. And where do we say this? It's a slant height, L, right? Right? So this diagram shows a solid object that consists of a solid cone sitting on the top of a hemisphere. Sitting on the top of a hemisphere, right? Let's say that the width of this is 12 centimeters. Let's say the width of this is 12 centimeters. And the height of the whole object, starting from this top till here, the height of this whole object is 14 centimeters. The height of this whole is 14 centimeters. Okay, now, for example, if I have to find out the total surface area, the total surface area of this solid, how I am going to work on it. Okay, so this total surface area of this solid means that we have to work with a cone and we have to work with a hemisphere, right? We have to work with a cone and we have to work with a hemisphere. So first of all, let's see, the total height is 14. So see, this is the radius. Obviously, radius is the distance from center to the outer boundary. So if this is, the whole is 12, it means that this is 6. It means that this again would be 6. So the height of the cone would be from here up till here. This height would be 14 minus 6, and that is 8 centimeter. This was the major thing that you need to understand this. That obviously this 6 was not given to you. You have to identify it yourself. How you find it out? You find it out by this radii. This was 6. It means that this distance is surely 6. And the height will be 14 minus 6. That would be 8 centimeters. Height of the cone would be 8 centimeters. The height of the cone would be 8 centimeters. So first of all, let us start with the curved surface area. The curved surface area of hemisphere. The curved surface area of hemisphere, right? As you know that the curved surface area of a sphere is 4 pi r square, right? So hemi means divided by 2. So it may gives you 2 pi r square, right? I'm not going to put the values of pi. I'll just give the answer in the form of pi, right? So 2 pi r square. So here 2 pi, and what would be the radii? It's 6. So 6 square is 36, and 36 times 2 is 72 pi. So 72 pi, we have the curved surface area of hemisphere. But we don't need only the curved surface area of hemisphere here. We need the surface area of cone also, right? Now, for curved surface area of cone, you know that the cone again, for the curved surface area of cone, the formula is, yes, it is pi r L, right? It is pi r L, the curved surface area of cone. As I have discussed here with you that the curved surface area of cone is, see, pi r L. So the curved surface area of cone is pi r L. It is pi r L. Do we have L here? No, we don't have L here. So first of all, we should know that how to find out this L. How we can find out this L. So this is a right angle triangle, right? This is a right angle triangle. And on right angle triangle, we can use which theorem? Pythagoras, for finding out the length. We have L, H, and we have this 6 here. With the help of these three, we can easily find out the value of L, right? So we can apply Pythagoras theorem as h square equals to p square plus b square. So over here, h is L square and p is, the perpendicular is, yes, this is 8, that is 8 square, and the base is 6 square, right? So this is L square equals to 64 plus 36, that makes it 100. So the square root of 100 would be 10. So the length is 10 centimeter. The length is 10 centimeter. The slant height is, that's not the length, sorry, it's the slant height. So the slant height of cone is 10 centimeter. The slant height of cone is 10 centimeter. The slant height of cone is 10 centimeter. So the curved surface area of cone that we'll be needing was pi r L. So pi is, just keep it as it is. The radius was 6 and the slant height was 10. So that makes it 60 pi. So in this way, I can find out the total surface area, the total curved surface area, the total surface area of solid that was, yes, 60 pi. We got it for cone, for the curved surface area of cone, plus 72 pi. That was for the hemisphere. So 60 pi and 72 pi. That makes it 132 pi centimeter, square centimeter. Be very careful with the unit. It is square centimeter. So this is the one example we have discussed. Inshallah, in the next video, we'll be discussing more examples, right? Okay. So in this way, we can solve a question by dividing it into simple chunks and by analyzing the question carefully, right? So in this way, we can get the total surface area of solid that was 132 pi square centimeter.